This is just an update on the MODBUS project that I was messing around with about a month ago. By building this test board. Uh, if you followed my video from last month, you probably noticed that, this board doesn't look the same. Well, that's because it isn't. I basically tore it down and rebuilt it. First thing that's different about it is I've replaced the WaveShare module. It turns out, while I was messing around on Amazon, it turns out they made a 32 channel version of this, these were what I was originally using, an 8 channel relay MODBUS module. And I had 2 of these installed, and turned out when I'd seen that they had a 32, it opened the possibility I could get all of what I need in a more compact, because as you can see, these would fill the slot about 2 of these, where I would actually need 4 to make up for what this does. In addition, this doesn't require 5 volts. This could operate on anything from 7 to 36. So that little 5 volt DC converter I had was eliminated. This just runs off 24 volts straight. And then as what was in the last one is this 32 input module, except this is now the NPN version instead of the PNP version. So the Amaron input block is now back to the IS16 type block, which is the same one that's on the train project. This is a solid state relay block that interfaces with the block detection on the track, goes through here, and then as the inputs, and then transmits that into the input module. As I explained in previous videos, the reason for having this is block detection is done by isolating one of the outer rails on the layout. If in the event the train had a derailment and say track power were to feed back into that outer rail, it could potentially cause a burnout, which would, blow one of these inputs out, which, would basically make this module useless. Instead, it has to go through here. These are more robust, but even in an event if it did blow one out, these can simply be pulled out, replaced, and back in business. Easy peasy. So this just provides isolation. Another thing that the old block didn't do is it didn't handle the photo eyes that are on the layout, which protect the remote switches. So I've now accommodated for the photo eyes, 8 of them on the layout, and the track switches I reduced to 4 instead of 7. I built the first module with the intention of 7 switches, but it's for basically a layout that I can't build. So in a way it was like, well, that was kind of stupid. So I build it more realistically, because this now can potentially make a major change to my PLC project. So now it's just the 4 remote Lionel switches, which route through the RSC lights, route through these converter boards, which right now you see one of them is being tricked into seeing one of the switches. I don't have any switches hooked up. I just simply put a 4.5 volt power supply to simulate one of the Lionel LEDs being on. Well, for the photo eyes, what I did is I added 2 of these opto-isolator solid state in between, in the event that, say, if there was a short circuit in one of the photo eye sensors. Given the fact that, this is basically a very inexpensive input module, I would make the presumption that it's not very robust and probably couldn't handle surges. So I put these as a buffer in between the photo eyes and the input module for the same purpose. Less likely anything would happen, but, if, say, the wire got crushed or whatever, or the photo eye sensor shorted out, it's just a little extra protection. And I have a bunch of these that were scavenged from old CD and DVD equipment. I got a ton of these, so I figure, might as well make use of them. So basically this is built now with the model of what my existing train project is, where I have 6 track powers, 8 photo eyes, 10 block detections. Although this this module handles 16 block detections. There's only 10 of them that are actually wired. The other 6 are just not connected. And being that I have 32 relays, this entire top block would handle all the signals on the layout, which is going to be this entire terminal block. Handles all 10 signals. This would just be the interface for the track power, reduce, and accessory power. And just the only thing that goes back to the PLC is, again, like the last, just 2 cables. You have just a 24-volt power supply to power the circuitry and a 2-wire serial port for Modbus communication. For the test, I have this other Micrologix 1400. This one was obtained used on eBay. I'm a very patient man. It's like when I'm looking for parts. I mean, typically a Micrologix 1400 is not exactly cheap, but if you're patient enough and wait around on eBay, there's a lot of times there'll be people that are scrapping equipment and will put the parts up for sale relatively cheap, used but cheap. So when the price was right, I strike and boom, I found this one. The only thing this one does not have, it does not have analog input or output, so this one can't be a direct replacement for what's on the train project, because I need analog input and output to handle the throttle control, where this one does not have that. That's the only difference, but it's very useful for a lot of other things. And this just shows the actual rungs of code that actually interface, to this remote box or remote panel that I built. It's actually relatively very simple. The top rung just simply fetches, reads the relays in one shot, all 32 of them, and I keep 2 elements of binary bits, which would be considered all the relay outputs, and the program would just write to them. So then it would see a difference between what it read and what it wrote. So then it would say, okay, now it would turn around and write those values out to the relay module, the wave share. So the only time it'll actually do a write command is if it sees a difference, like when one of the values changes. Otherwise, it just reads it and moves on. And then the third message command is what reads the input board. It's a little different how that gets read, but it's not hard to interpret. It just basically has to be read in as 2 integers instead of 32 bits. So that last command I have on there with the copy, all it does is it basically takes the 2 integers and just splits it up into individual bits spanning 2 16-bit binary bits. So that's the reason why there's that copy command at the bottom, so that they can be broken out into individual bits like they should be. But relatively is very little coding required to interface to this Modbus board. Now, I don't actually have it connected to anything in the train project, so right now I'm just showing I have 2 block detects and 2 photo eyes just by simply connecting jumpers, to simulate. And I have one of the quote Lionel remote switches reading in a throughway position just by feeding in a separate 4.5 volt power supply to what is called RSC lights. So by writing a little quick program or on the HMI, this would be like, okay, for turning on the track power, I could as I turn on each thing, let's say the corresponding relay will turn on the track power. And I also have provisions like I did, on my small panel. I have a way to remotely select manual or automatic mode if I'm not at the pedestal. Those will also activate 2 relays. And here is where the remote switches would be thrown. I had to go back to using individual interlocked relays for each point switch, because it did turn out it did cause problems with the first version of the Modbus board. I thought the whole problem was because of the time, I was trying to use block detection on the switches, and then I had to rewire the train project to separate everything. It turns out the real problem is with the difference in these Lionel switches. When I originally built the first generation project, these switches were simply called remote switches, and they operated off these levers and nothing else. But the newer versions are now those command control switches, which is part of their like remote control system, and they do not like to have floating grounds. So it had to be done so that one relay will close the throughway side. The next relay will close the turnout, which would have the same effect. It's going throughway, turnout. But the relays are interlocked so that you cannot hit the touch panel won't let me hit two at a time, but even if it would let me, because these relays are single pull, double throw, they're mutually exclusive. So if one's closed, it prevents the other one from making contact. And because I have one of the RSC lights active, it shows that switch is pointing to the throughway, which would be if these were glowing green. And on the last screen, this just shows the block detection and photo eye with the ones that I've simply closed, with the jumpers, showing 2 photo eyes and 2 of the block detects. Some people have wondered how to read and write the wave share using RS Logics. So this is the actual message command if you want to read the wave share 32 module in one shot. All the 32 channels will be read in and be read into B10 element 0 and 1. Because you're reading in 32 bits, it's going to fill in B10:0 and B10:1. The write command, which would actually change the relays, is not much different. Just it's function code 15. And you'll see that the data table address is B10 element 2 starting at bit 0, but because I'm telling it to transmit 32 bits, it's going to also include element 3. Just so you know. Yeah, it has to span across both binary bits, which that could throw some people off not realizing that. Now the 32-bit input module is a little bit different. You have to read its holding registers, which are integers. So you're only going to read in 2 elements because they're 16 bits each for a total of 32-bit inputs. The one thing to note is when you do get the documentation, it says the addresses, you have to address it in hex mode. RS Logics does not support hex addressing, so you have to convert it to decimal. So in the case of this input module, it says it's addressed C0, so you just have to convert it to decimal, which is 192. In RS Logics, though, you bump it up the address by 1, so that's why the address is listed as 193 for Modbus address 40193. It took a little bit to figure out that you have to add 1, even though it's addressed C0, but when you're dealing with some of these inexpensive modules, well, that's what it takes. So this way you know what the addresses have to be for it. Now, what could this board potentially do? Well, by looking at the engineer control panel, what it can actually do is eliminate about half of the cabling that goes in and out to this engineer control panel. This left side here, these cables go out to the layout, up onto the track level. This entire section goes back to the PLC. And then you have the control section, because you basically have the automatic control of the track power and switches coming in on these cables, and they get routed through these automatic manual control relays and then sent out to the layout. So it's basically these relays that choose if this has control of the layout or the PLC has control of the layout. So what this could do is basically, by moving and moving, I could eliminate all the automatic and manual control relays and move them back onto the PLC panel, therefore eliminating basically this entire row of cabling, which would save cabling and weight. It would also change, like you have the engineer control panel coming in, and like I said, this heads out to the layout. This is all the automatic control of the track power and switches coming into the engineer control panel. You would basically, these cables would just get moved to the PLC, and you'd only have one set going over, which would just be, this would be the manual control of the layout coming into the PLC control. But the most significant difference that it would have would be on the actual PLC controls. Because here, this entire block of relays, like this section here handles all the signals, which would now be handled by the MODBUS board. This handles all the track switch throws. And there's just one in here that handles the little tower light, which would stay. And then this is all the track power. So basically, all these relays, except for one, would be eliminated. And of course, this, exists on the MODBUS board. So then this would go, well, it depends. If I could integrate, actually integrate all of this in by limiting this would free up some space. Those two little boards, I would keep this because this does the same thing. It's the 5 volt to 24 volt converter, but this handles all 8 inputs. And it would actually mean all these external I/O modules, add additional expansion modules on the PLC, would also be eliminated. I wouldn't need them anymore. So possibly with some measurements, maybe all the components from here can be put into here. And that could, I would eliminate having to put up a second panel. And like I said, it would simplify the wiring between this controls and the engineer control panel. Just have to do some experimentation because being that it is serial communication, it would be a little bit slower. But for the train project, it really shouldn't matter. It'll be interesting to see where this goes, and it would be a significant undertaking to do it. Not sure if I'm going to, but this does make things interesting, because if I wanted to add on to the PLC project, now things like these could be added remotely. And they don't even have to be they could be even up on the layout and just running a serial, an RS-485 cable up there. So, this could get really interesting. But again, for now, take care.